hope you're all having a great day. If you're new here, welcome to the channel. Today we'll be looking at the Carvera Air. Now, Makera wanted to send me one of these machines for free, and I agreed, provided they would let me give my honest opinion about the machine. Now, I'm not a review channel, but I do think I offer a unique perspective on this because if you're new to CNC, I've been in your position and started many years ago with the basic 3018 CNC, and just a few years later I designed and built my own CNC machine, which I've actually open sourced to the community over on my website. So before I take on reviews like this, I always like to conduct my own research to see the other reviews that people have done. I do this so that I can try and fill some of the gaps that other people avoid, and for me to also avoid duplicating content as well. What I notice with this is that a lot of the content creators that have been given this machine by Makera don't really test it properly. They just end up showing the demo projects that Makera provide, which to me doesn't really give a true reflection of the machine's performance. So for this video, we're not going to spend too much time with the demo projects. Instead, we're going to focus on some completely unique projects that I created myself using various software packages. So here's a timestamp list of what I'll be covering in this video. I hope you enjoy. The Carvera Air found its way onto Kickstarter after the success of Makera's flagship machine, the Carvera, which also had its own successful Kickstarter campaign. The Carvera Air set itself out to be a smart and versatile desktop CNC at a much more affordable price. It's still pretty expensive, but it's half the cost of the flagship machine. You can now purchase both of these machines directly via the Makera website. Makera sent me the machine along with the accessory pack, 4th axis, laser module and PCB kit. This all arrived together in one large box weighing over 35 kilograms. The machine itself is very heavy, and you'll almost certainly need a second pair of hands to help you get this thing unboxed. You can see here what is included, and I have to say I was very impressed with just how much is included when you buy this machine. They genuinely do send you everything you need to get started with the demo projects, even the materials. The machine features a one-piece solid die-cast aluminium frame, making it very rigid and excellent for working with harder materials. The X and Y axis feature dual 20mm linear rods, and the Z axis features dual 15mm linear rails. All three axes are driven by ball screws. The Z travel is 120mm, and the working area is 300 by 200mm. The bed is a solid 8mm aluminium plate with a 15mm waterproof MDF board on top. The board features threads that allow for spoil board and work clamping, and the spindle is a 200-watt brushless motor with a unique quick lever tool changer and a auto tool height system. The rear of the machine features typical I/O such as mains power, data, charging, emergency stop, as well as an air input connector and external vacuum connection. The machine operates via Makera's own Carvera controller, which is available on Mac and Windows. It can also run entirely on any Android or iOS device, and they do include a swivel bracket which can mount to the side of the machine should you want to do that. So now that you know pretty much everything there is to know about the machine, let's briefly cover some of the example projects. Makera include two high-quality booklets with the machine. The instruction manual is 52 pages and covers all features of the machine. The examples guide is also an excellent way to get familiar with the machine and ensure you have understood CNC preparation such as spoil boards and work holding. It's also worth knowing that this information is all available over on the Makera wiki. I'll leave a link in the description below. There are 4 examples in the guide: an LED light, laser engraving, 3-axis relief and 4th axis relief. I only did 2 of the examples, which were the LED light and the 4th axis relief. The LED light example is great because you actually get to learn and make something cool in the process. If you bought the PCB kit, the first thing they have you do is mill out a simple PCB. The PCB kit includes additional bits and things like solder mask and double and single-sided copper boards. They do also include a pre-built circuit so that you can complete the project even if you didn't order the PCB kit. I'll be covering PCB capabilities in a separate video in the future, so make sure you're subscribed not to miss it. Next, they have Umilla base from ABS. The G-code for these projects are preloaded onto the machine and accessed via the Carvera controller. The guide covers all this in great detail. You then carve an image into a sheet of acrylic using an engraving bit, and then cut that shape out using a end mill. After completing that, you mill out a small switch button from an aluminium plate, and when you put everything together, you end up with this touch-controlled LED lamp that illuminates your engraving. On reflection, I do think this was a fantastic starter project. It nicely demonstrates all key elements of CNC machining, such as work holding, tool changing, Z probing, and working with different materials. The next example project I was personally very excited about, which was the 4th axis relief. I had never done any 4th axis milling before, so this was very much a learning experience for me. The 4th axis module is very easy to set up. The two ends of the module can be loosened to slide, revealing 6 fixing points that bolt down to the MDF board. The materials pack includes an epoxy tooling board which can easily be fitted into the rotary axis. The 4th axis plugs in at the back inside the machine with a safety clip to ensure the cable is safe. There are 2 tool paths here. The first tool path uses an 1/8 inch single flute end mill for a roughing pass, which clears away most of the material. The machine seems to do this very effectively, and it's extremely satisfying to watch. The second tool path uses a 30° 0.2mm V carving bit to finish the model for detail. The result of this was impressive, and the example did its job in that it helped me understand how to work with the 4th axis. So this is where I left the example project and moved on to some custom projects so I could really get to know the machine. To summarize, I thought the example projects were great in demonstrating how the machine operates. It doesn't teach you about CNC as such. There's still a lot of background research that you'd need to do in regard to work holding, speeds and feeds. But I thought it was a very nice balance for complete beginners that gets you actually using the machine quickly so that you don't feel too overwhelmed. So me being so interested in the 4th axis of the machine, I thought I'd really give the machine a challenge and try a 4th axis relief of my own using a cut-off of copper beech, which is a very dense hardwood. In terms of pushing the machine with woods, it wouldn't really get much more challenging than this. I decided to try out Makera's other software package called Makera Cam. I'll give my overall thoughts about the software towards the end of the video, so for now we'll just focus on the projects. Makera Cam allows you to create both 3-axis and 4th axis projects. The option to work with 4th axis projects and generate the G-code is impressive. I downloaded this 3D relief model from the web and began to set up my project. I was able to successfully follow one of Makera's own tutorials, which clearly explained most of what I needed to know. I managed to achieve a successful relief on my 3rd attempt. There were a few things that tripped me up along the way, which I'll explain now. One of the first things was understanding the work origin offset and how this needs to be configured in the Carvera controller. We only need to concern ourselves with the X-axis offset here, and what this refers to is the distance from the right edge of the headstock. I've demonstrated this here with a ruler so that you understand that wherever you set this distance is where the origin of your model will start. The other thing that tripped me up is setting the Makera Cam software setting, which was enable tailstock. On my first attempt, I disabled this setting, which caused the toolpath to cut right to the end of the tailstock. This turned out to be a problem because despite my stock dimensions being correct, the generated toolpath actually went beyond the stock material and eventually started milling into the thread on the tailstock tip. I quickly realized this and I was able to use the emergency stop to prevent any further damage. Now, this was either a headstock offset issue on my part or likely a bug in the toolpath generation where it didn't account for that offset. I think this is where the software could really benefit from some safety features like the sort of collision warnings you'd see in something like Fusion 360. To mitigate these risks, a great tip here is to just always ensure that your stock material is a lot longer than the relief you intend to cut, accounting for your headstock offset and having that tailstock enabled. Maybe this is standard practice with 4th axis machining, but it's something I had to learn the hard way using Makera cams specifically. So on the 3rd attempt I dialed in my settings correctly and the result was a success. I began with this roughing toolpath to remove as much of the excess material as possible. After completion of the roughing toolpath, I ran a finishing toolpath which completed with no issues whatsoever, and the result was very impressive. This is a nice 4th axis relief in a copper beech hardwood. Each end of the stock can then be removed using something like a multi-tool and then sanded down carefully to create your finished product. Next up, I thought I'd try out a regular 3-axis relief, again using a piece of copper beech hardwood. This time though, I wanted to use some third-party software and test out the profiles that Makera provide over on their website. I think this is important because most people will likely use their own preferred software packages when working with this machine. So for this relief, I decided to use Carveco. Carveco, formerly known as ArtCam, is very popular and I've used it for many years. I bought this awesome 3D dragon relief on Etsy, imported it into Carveco, generated my toolpaths, and then exported those toolpaths using the Carvera profile provided. There are 3 toolpaths in total for this project: roughing, finishing, and then a contour to cut out the relief. For work holding here, I decided to revert to the trusty old tape and glue method, which is my personal favourite. Makera did a pretty good job with the clamps and work holding for this machine, but personally I've always disliked clamps as they increase the risk of collisions and they make it difficult when trying to do a contour toolpath, for example, where when the cut's completed the workpiece can just sort of freely move around, and this can cause some problems. For the finishing pass, I opted to use the spiral finishing technique, which has also given me the best results with 3D reliefs in the past. Using the contour toolpath, I was then able to easily cut out the shape of the relief, with the workpiece still held in place thanks to the tape and glue method. I cleaned up the edges with some sandpaper and the result is very impressive. The Carveco profile provided by Makera worked with no issues at all. Next up, I wanted to try out the Fusion 360 profile provided by Makera. What I like about this is that not only do they provide the machine profile and the post-processor, but they also provided all the tool profiles and their associated material settings. This really impressed me and it did genuinely make getting started in Fusion 360 so much easier. For this, I had a very real and practical part that I needed to mill from aluminium. So this is my own CNC machine that I designed and built using basic tools here in my workshop. I've open sourced it and it's available over on my website if you're interested. The part that I needed to mill for this is an upgraded Z-axis NEMA motor bracket. And what better way to do that than to test it out on the Carvera Air. So I got started and set up my Fusion 360 cam project. One thing you need to ensure here is that your model origin matches that of the Carvera controller, which is the bottom left corner. You also need to ensure that your axis directions are correct. If you get this wrong, you'll have an absolute nightmare trying to figure out why the Carvera controller is not positioning your part correctly. I manufactured this part using 3 toolpaths. The first toolpath was a pocket operation using a 1/8" single flute end mill. The second operation would pocket the smaller 5mm holes using a 2mm single flute end mill, and the last operation would cut out the part using a contour with an 1/8" single flute end mill. Again, for work holding here, I decided to go with the tape and glue method because it just makes things so much easier. All toolpaths seem to run fine with no issues at all. Worth noting here though that I did not use any oil or air assist, and I did that deliberately to see how the machine would hold up. One thing I'd really like to give credit to here is the protective shield on this machine. I know Makera have tweaked this shield a little bit based on prior review feedback, But I have to say I didn't have any issues with it, and it does do an excellent job containing any waste material. The only place where dust and chips did manage to escape was the underneath of the machine, where it fell through the gaps that allow the Y-axis to move forwards and backwards. Unfortunately, there's not really much you can do about this, since the Y-axis has to be able to move somehow. The part was cut out very cleanly, and after some minor sanding and polishing, it looked like a brand new shiny part ready to be installed on my DIY CNC. After gaining some confidence with Aluminium and Fusion 360, I decided to run a step-down test on some 15mm pockets. I always keep this old 20mm thick piece of stock aluminium around, and I often use it for tests like this. I also figured that deep pockets would be a great way to test out the air assist capability on this machine, since weaker air assist methods will usually struggle to clear chips from deep pockets. The air inlet on the back of the machine expects an 8mm outer diameter tube, and fortunately I had some of this lying around in the workshop. I was also able to use the air assist module from my X-Tool S1 and connect the 6mm tube directly into the 8mm tube, as the inner and outer diameters were a perfect match. Near the bottom of the spindle there's a metal tube that can be adjusted for both airflow and direction. I set mine to maximum airflow as I didn't want too much back pressure on the air pump. I got started with the test and immediately I could see that the air assist was very effective. You can see here where I'm manually switching the air assist on and off, and just how quickly it manages to clear the chips away. It was also very capable at doing this even at maximum pocket depth. As the tests went on, the waste material that comes off the aluminium tends to be larger due to the increased step down height. This proved to be no issue for the air assist, and it was still able to successfully clear the chips. I think with smaller pocket holes it probably would have become more difficult to clear away those chips at the maximum depth, but this is not only a problem specific to this machine, this is just a general common CNC challenge, and why anyone serious about metal milling will tend to use a compressor system like the Mist Buster. I also measured these test pockets for accuracy. The design dimensions were 22mm, and in the real world we had an accuracy range of 0.01 to 0.03mm. Not bad for a machine of this spec. I also thought this would be a great opportunity to talk about the dust extraction outlet. Now, the diameter of the outlet is 22mm, and I thought this was kind of strange because that's not really a generic size, at least not here in the UK. For example, on my DIY CNC, I have a large 1kW vac, and that has a 65mm diameter hose. And I wouldn't dream of connecting this up to the Carvera Air, just because it's going to be running overtime. So what I did in the end was design a 3D printed outlet in Fusion 360. I 3D printed it, and I was able to connect that up to the machine and also connect up to my 650 watt Henry vac. Something like this is probably a better option because it's lower power, quiet, and it does also have adjustable vents to compensate for higher pressures. The Carvera Air does also come with a magnetic detachable dust boot, which seemed to work quite well, and I didn't use this for filming because, to be honest, it's a lot easier to get footage without a dust boot. I did briefly test it here with the whole system hooked up, and you can see that it's very effective at picking up both wood chips and metal chips. But a little bit of safety advice here: if you're going to collect metal chips with a vac, make sure you're not mixing them with any wood chips, because metal chips can often get very hot and potentially cause a fire in something like a dust bag with wood. For the next test, I thought I'd really push the machine probably beyond its realistic limits, to be honest with you, and I thought I would try to mill some mild steel. Now, there's generally a good rule with machining that you shouldn't mill anything that is tougher than what your machine's built from. Remember, this machine is built from aluminium. The reason for this really is that it can put a lot of stress on the machine itself and also significantly reduce the lifespan of your bits. That being said, for the benefit of you, I thought I'd give it a go anyway. I bought these mild steel plates online, which are generally used to practice welding. So the first thing I tried to do was cut out this simple spur gear. Due to the limited size of the spur gear on this material and the number of teeth it had, I had to opt for a 2mm end mill to ensure that I could mill out the insides of the teeth properly. I was using a much smaller step down of 0.05mm, and the job was successful about 90% of the way down, and then the bit snapped. In hindsight, using a 2mm bit for my first test on mild steel probably wasn't a wise idea, just due to the high cutting forces. Following this, I decided to try and cut out a much simpler part, but this time using one of my own 4-flute 3mm end mills. At a 0.05mm step down, the machine once again proved to be very capable, seeing the job right through to the end. Bear in mind that I was also using no oil for this. Now, like I said, you probably wouldn't want to use this machine for cutting mild steel day in, day out. It is, however, good to know that if you do have the occasional project part that needs to be very strong, this machine is capable of doing it. If you have the time to spare, you could even lower the step down height, which would be safer and reduce any excessive vibration on the machine. For this next project, I wanted to try and create a metal 3D relief, which I had never done before. My choice of material for this was 3mm thick brass plate. To create a design for this, I decided to return to Carveco and reuse the Dragon 3D relief from our previous example. I created a brand new project, set up my tool paths, and adjusted my tool settings to correspond with the material speeds and feeds from Fusion 360. I had to do this manually as there were no tool profiles included for Carveco. Just like the previous Dragon example, this was done with 3 separate tool paths: roughing, finishing, and a contour to cut out the relief. Once again, the machine made easy work of running these tool paths. Brass is slightly stronger than aluminium, so it will put a bit more wear on your tools, but again, this made for a good test. The result was excellent, and I was very happy with this as an outcome for my first ever 3D metal relief. Remember, you can spend time dialing in your settings to try and achieve even better results here, and if you've got the patience, you could even do a second pass, which might even clean it up even more. The edges here did need a bit of cleanup with a sander, but this is standard practice when you're milling anything. You can see the end result is very good. For the final test, I wanted to try something that I was personally really excited about, and that would be a aluminium 4th axis 3D relief. This to me would be the biggest challenge for the machine, and honestly I had absolutely no idea if it would succeed or not. So I sourced another 4th axis relief model online and jumped back into Makera CAM to set up the workpiece and generate my tool paths. Keeping in mind everything I had learned from the wooden 4th axis reliefs, the only thing majorly different about this was the lower step down height due to us working with a stronger material. My piece of stock material was this 45mm diameter aluminium rod. Just like before, the one end of the stock was fixed to the headstock of the 4th axis, and on the other side I had to pre-drill a small hole to ensure that the tailstock would be held strongly against the much larger cutting forces. I originally started out with my own 4-flute 3mm bit because I was concerned that the bits included with the machine would have collided with the stock material at the collar of the bit. These other bits I had on hand were longer and would have allowed for clearance, but as you'll see, I had to swap this out for another bit later on. I loaded my G-code onto the machine and it started off well with no issues removing material at a step down of 0.2mm. However, after a while I noticed that the bit had seemed to have moved further upwards into the collar. The reason for this is that I forgot that the collar was actually for 1/8 inch bits, which are 3.175mm in diameter, not 3mm. After the bit had gotten warm, the collar that I had installed came loose, allowing the bit to travel further up the collar due to the increased forces. It wasn't loose by any means, but the cutting force was enough to push it back up. So at this point I stopped the job, realised my mistake, swapped the bit out for another 1/8 inch single flute end mill, which was included with the machine, and also to address my concern with the collar collisions, I modified the original project file and added another step down to the relief, which ensured there'd be no collision. I reran the job and the milling resumed as normal. It's really fun to watch the 4th axis in action, especially when working with a stronger material like aluminium. To my surprise, the job completed successfully, which led me nicely into the finishing pass. So for the finishing pass, my concerns regarding the collisions were very valid, and as you can see, the V-carving bit included with the machine would not have been able to reach where it needed to go, and ultimately would have collided with the model and ruined the job. I therefore decided to use some tapered ball nose bits. These were not included with the machine and were my own. I've always preferred using ball nose bits for reliefs. The bits last much longer, and often you can get just as much detail in much less time, but just be sure that you set your step over to be around 8 to 10% of your ball nose diameter, because otherwise you end up with these noticeable lines on the relief. I decided to start with a 0.5mm radius ball nose bit, and I was expecting this fully to break, to be honest, because of how fragile it was, and my concerns with that did prove to be true, and the 0.5mm radius bit did break about 1/3 away through the job. Remember, this is all a learning experience, and this is always the case when trying anything new on CNC. Expect this to be a standard part of your workflow. It was with mine here, so I just swapped out the bit for a 0.75mm radius bit, which would obviously be a little bit stronger. It would result in a little bit less detail, but I reran the job, and to my surprise it completed successfully, and the result here is pretty good. To summarise my thoughts on this project, I have to say I was very impressed. It certainly isn't perfect, but was definitely a seriously impressive achievement for a machine of this size. Also keep in mind that this was just my first attempt, and had my step over, step down or feed rate been smaller, it's likely that the result could have been even better. You can also do a second pass, like I said before, which generally improves the finish, especially on metal. So let's summarise my experience with this machine. I have to say, I really do like this machine. From a hardware perspective, there is nothing else really out there as capable as this machine in such a complete desktop format. When you buy the machine, it comes with everything you need to get started, which is very valuable, especially for a beginner. When using the machine, it's clear that a lot of thought went into the design, and not just the design of the machine, but also in dealing with that intimidation factor that will undoubtedly be present in any beginners stepping into the CNC milling world. Makera have done a fantastic job of minimizing that intimidation, and those examples at the start are very good at doing that. The machine is well built, and the unique tool changing system does speed up the workflow. The thing that I feel could have been better about the machine is the bundled software. I want to be clear that the software is very usable, it just doesn't feel polished. I ran into a few bugs and issues during my experience. Sometimes the Wi-Fi connection would drop out, which doesn't affect the running job. The machine will keep running whether it's connected or not. However, if you then want to pause a job or change a setting, it can be frustrating with delays and sometimes often struggling to reconnect to the machine. The alternative is running over a USB, but what I found with that is that file uploads seem to take much longer, and that could be quite frustrating as well. This did also cause some other issues where if, for example, you were impatient and you hit the run button twice, given that the machine didn't respond on the first attempt, it would result in every line of G-code being run twice, including the initial probing. And I assume this is just a bug in the software. I also experienced some random 4th axis soft limit triggers after I'd been using the 4th axis. This seemed to happen even when the 4th axis was disconnected, and I wasn't really sure what was causing that. The only way I was able to resolve it was to switch the machine off and back on. Again, that could be some kind of hardware or even a firmware bug. One other thing I noticed with the software is that the estimated job completion time in the Carvera controller was very inaccurate. Sometimes estimating 100+ hours of remaining time for jobs that were only 7 or 8 hours long. This seemed to be consistent no matter what software the G-code was generated from, whether it was Fusion or Makera's own Makera CAM. It seemed to just be a consistent problem. One other thing I do wish also was that Makera sent me more collets. They did provide me with the 1/8 inch and 1/4 inch collets. However, being in the UK here, I do have a lot of my own bits that use the metric system, which would have been nice to use with this machine and try out. I do believe that they sell them over on the website at sort of the standard 3mm and 6mm sizes. So if you plan to buy this machine and you have existing bits like me, I'd recommend picking up the existing collets as well that they do sell. I will say though that the provided profiles for things like Fusion 360 and Carveco worked flawlessly. I had no trouble at all, and I was really pleased about that, because like I said, it just makes things much easier when you can integrate those tools with your existing preferred software packages and it just works. That's always really nice. For me, the most impressive thing about Makera Cam is the ability to produce those 4th axis toolpaths. I thought that was probably one of its standout features for me. Overall, the controller software is okay, but what I would say is don't be surprised if you're sat there scratching your head a couple of times when you run into a few bugs that don't really seem to make much sense. I'd actually be really interested to see if this machine could be paired with a different controller like Universal G-Code Sender, for example. So it begs the question then, should you buy this machine? And after using this machine for a solid 2 months, would I be happy if I had paid for it? And my answer to that question is yes, I would. The hardware itself, it seemed to be pretty flawless. I think the issues that I did run into with the bugs are probably on the software side. The machine itself is very well built, and as you saw there, it churned out some amazing projects on a wide variety of materials, on multiple different software packages, and they were all my first attempts. If you really dial it in and get used to the machine, I'm sure it can produce even better results. Like I said, the good thing is this software will likely only continue to be updated and improved as Makera go on to produce more products, whether that's software or hardware. They're getting a lot more support, and it's good to see that, genuinely. It's nice to see people trying to create their own tools and branching away from things like Fusion 360 or Carveco. But remember, Fusion 360 didn't get to where it is now overnight. People complain about having to pay for that software, but ultimately it's brilliant. It does what you need it to do, and I think Makera can get there with this software. It's just going to take a bit more effort. I think they need a bit of UX, UI, and I think it can genuinely be improved a lot. I do think though, from a project design perspective, you're more than likely going to quickly find yourself wanting to switch to something third party anyway, because like I said, they're more developed, they're more advanced, more experienced, ultimately are just more friendly to work with. Now if you're a beginner and you're really thinking about buying this machine, the main thing I would like you to think about is, what do you want to do with the machine? The reason I say that is that this is a small form factor machine, and you are going to be very limited in terms of what projects you can do on this thing. Take it from me, somebody who started off with a small CNC, I found myself quickly outgrowing it, and hence me building the machine behind me. I sort of seeked out a solution to get a larger machine for a cost that's actually lower than the Carvera Air. You really want to think about that and understand where you want to go with CNC. To put it bluntly, if you're a hobbyist and you only ever want to work on small projects, then this really is the perfect machine. If you have the disposable income and you want to buy a machine that will make learning CNC as easy as possible, then this also is the perfect machine. Even for someone like me, who now owns a larger CNC, I will always keep the CNC in the workshop. It's going to be incredibly handy actually for smaller metal project parts, and even those custom PCBs, which I think is another really unique selling point for this machine. I'm almost certain as well that I'll be doing a lot more 4th axis projects on this too, as I found those fascinating. So there we go guys, I hope you found this video useful and informative. I tried to approach it from a place where I saw other content creators lacking, in terms of actually trying projects, actually using the machine and seeing how it performed, trying to do things that weren't the examples. I hope that came across in the video, and I hope I've given you a true reflection of how I feel about this machine and given you a better insight as to what it's about, what are some of the issues, and is it worth buying for you and your use case. If you are interested in buying the machine, I have a unique £100 discount code that is specifically for my channel, and that's valid for the next month, I believe. They also have a sale on at the moment, and I do have affiliate links down in the description below. You don't have to use those affiliate links. You can use my discount code and I don't gain anything from that. So it's completely up to you whether you want to support the channel or not. I always like to be completely transparent. So I'll leave all that in the description, but thank you so much for sticking with me through this video. I hope it was useful. I hope you learned something. Have a lovely day, and I'll see you in the next one.